Okay, suppose that f of t is a vector function that traces out some curve with varying values of t, some curve in the xy plane. And of course this could easily be extended to 3 dimensions. This could be a function of x, y, and z with I, j, and k components. But let's just assume now we have a function f of t. Now, f of t is considered to be rooted at the origin. Its initial point is at the origin, and the tip of the vector is at the point on the curve. And as t changes, f of t changes. Now both the length of f of t can change and the angle of f of t with the positive x-axis, that is, the direction of f of t can change. I've extended a dotted line out here in the direction of f of t, and this is the radial direction of the vector f of t. Now if you let t change a little bit from t to t plus delta t, that is, if you let the argument of f of t change from t to t plus delta t, then we're going to get 2 vectors, f of t and f of t plus delta t, and delta f is the vector that goes from this point to this point, from the tip of the f of t to the tip of the f of t plus delta t, and as we've seen, delta f is just the f of t plus delta t vector minus the f of t vector. Now let's look at a slightly bigger picture of the same thing. Here's our f of t, and here's our delta f. Pretty much in the orientation we see it in this picture. I haven't drawn the rest of the picture, but we understand that we have an f of t, here we have an f of t plus delta t, and here's the delta f, the difference between those 2 vectors. The change in the position in our xy plane is the vector delta f. Now that vector typically, the f vector can get longer or shorter, and it can change direction, as we've seen. And in the case we have here, we see that the f vector gets longer between these 2 points. Now if the f vector gets longer, that means that the component of delta f in the radial direction is positive. Delta f component in the radial direction indicates whether f gets longer or shorter. Now when we calculate the derivative of f by taking delta f over delta t and allowing delta t to approach limit 0, if delta f is tending to get longer here, then the delta f component in the radial direction will be positive. If delta f tends to get shorter, the delta f component in the radial direction will be in the direction opposite the radial direction. So if it gets longer, we have a positive delta f in the radial direction. If it gets shorter, we'll have a negative delta f in the radial direction. Now we also have the component of delta f component, the delta f component perpendicular to the radial direction. And this occurs when f changes direction. If f didn't change direction, as could easily happen, we could have f of t and f of t plus delta t being another vector in the same direction, so that f of t changes only in the radial direction. However, if the angle changes between argument t and argument t plus delta t, then we're going to have a delta f component perpendicular to the radial direction. Now, f of t could change in the clockwise direction or in the counterclockwise direction. If f of t changes in the counterclockwise direction, then the component is in the radial direction will be in this direction, rotated in a right-hand sense with respect to the radial direction. If this delta F component, or if F of t is changing direction in the counterclockwise direction, then, I'm sorry, in the clockwise direction, then the delta F component will be back this way.